Okay, last one, guys. We got two videos in the can, and now we just gotta get this one to work. So we're going to be looking at some other techniques of integration, and one focuses on inverse trig functions. And it's, what do I do if the integral is not quite what I would want it to be? Like if this was 1 plus x squared, I know what the antiderivative of that is, right? That'd be tangent inverse x. But it's 4 plus x squared, so how do I deal with that? What I'd like to do is I'd like for us to develop the formula, to figure out the formula by us going through the problem using substitution, and then we'll see the formula on the basis of that. So what we're going to do is we're going to say, well, okay, this is, I really wish there was a 1 there. Sorry, I spaced out there or freaked out. I really wish there was a 1 there, so I'm going to do some algebra to put a 1 there. How am I going to do that? Well, I'm going to factor out a 1 out of the bottom. So it's 1 over 4 times 1 plus x squared over 4 dx. And so that 4 I could just move out in front. So it's 1/4. And now I'm closer to inverse tan because now I've got a 1 there, like I'm supposed to have in the formula. The only problem is I've got an x squared over 4 there. I don't want an x squared over 4. I want that to be an x squared or whatever. So we're going to do u substitution on this one. You could Lindstrom this, but we're going to do it with u substitution. And what I'm going to do is I'm going to take this x squared over 4, and I'm going to rewrite it as x over 2 squared, because that helps me see the inside function. It's just x squared over 4. I've rewritten it. So it's 1 over 1 plus, it's not x squared, but it's x over 2 squared. All right, I'm going to make u equal to x over 2, because when I substitute that in, I'm going to have 1 over 1 plus u squared, and it's going to look like it's going to be an inverse tan. It's going to be ready for an inverse tan antiderivative. There we go. That's the language I want to use. So du is 1/2 dx. You could pause the video and practice this as a substitution problem, just so you can get some substitution practice. That would totally be okay. Or if you're like, all right, I'll just kind of check it out, that's okay too. So, all right, so I got the 1/4 that's sitting there, and I've got the 1 over 1 plus u squared, and boy, I like that. But now I've got this dx, so I don't have any tricky way to do it, so I'll just solve for dx, and I'll turn that into 2 du. Cool? All right, so now that 2 I can put out front, and so, because it's a constant multiple, so that would be 2/4 times tangent inverse of u, which is just 1/2 tangent inverse of, now I'm going to put the x in, it's not u, it's x over 2, plus c. And there's my answer. When I first was teaching calculus, I just had students do this by hand, because I often try to avoid having you memorize more than I think you need to. And you can do this by hand with an easy substitution. But some students found it really handy just to have this one memorized. And so we're going to develop it as a formula, as a general formula. What happens if you have the integral of 1 over, not 1 squared plus x squared, but some other number squared plus x squared, just like we did up above. And so it's the same problem. It's just not a 1. I just have to deal with the fact that it's an a instead. Well, you could do the same exact thing. You could factor out 1 over a squared. That was our 1/4 that we factored out. You can follow along comparing it to this one. And in the bottom would be 1 over 1 plus x squared over a squared dx. Just like we had x squared over 4, this is just x squared over whatever that number is that's sitting out in front. Now I'm going to do the same exact thing and rewrite this as x over a squared, just to make it easy for me to see the substitution. And so u is x over a. Remember, a is just a constant. So du is just the derivative of x is just 1. So it's 1 over a dA, just like we had not dA, dx. Just like we had 1/2. This would be 1 over a. Cool. And then, so I can multiply the a up. And so I can turn this into 1 over a squared times the integral of 1 over 1 plus, and now it's u squared. And dx becomes a du. Sorry, my writing is pretty bad here. Pop the a out in front. So that's a over a squared. So that's 1 over a. Like when I combine this and this. 1 over 1 plus u squared would be tangent inverse of u. So now let's turn it back to x's. So it's 1 over a tangent inverse of x over a plus c. And you can see how it totally parallels our answer over here. When we were doing this problem, this was on my a squared. So a was 2. Just treat it as a positive. Don't worry about a negative. And so a was 2. So my integral that I ended up with is 1 over a. So that's 1 over 2. There it is. Tangent inverse of x over a. So that was x over 2 because a was 2 plus c. So you can learn the steps to do this yourself, or you could just learn the formula at the end. And I'll be honest, if you memorize the formula, then these problems become pretty fast. But if you don't memorize the formula, it's just substitution, and so it's not that bad. Substitution with a little algebra, that factoring is a little weird for people because it makes fractions. And so if I gave you a problem like the integral of 1 over 16 plus x squared dx, you can just go, oh, okay, a is 4. And so it's 1/4, 1 over a, tangent inverse of x over 4 plus c. It's kind of easy to do, like if you memorize the formula, but for some of you, it would just be easier to substitute. You take your pick. There'll be a problem like that on the test when we get to the test in a couple weeks here, or at least a week and a half. And so you'll see it soon. How about this one? This is a sine inverse one, and instead it's got a 9 minus x squared. And so, how do I deal with that? And you could see that we're going to kind of do the same thing. The cool thing about this one is when you factor out the 9, you do the same exact thing. We're going to factor out a 9 out of this. So it's the integral of 1 over square root of 1 minus x squared over 9. Whoop, I need to factor out the 9. So it should be there. So let me rewrite that. Erase. Square root of 9 times 1 minus x squared over 9 dx. I haven't substituted yet. And so that 1/9 is multiplying this, so I can pull it out of the square root and make it a 3. So that's going to be 1/3 on the outside. All right, cool. So that's that part. And now I could do a u substitution and make u equal to x over a again. U equals x, x over 3. Because that's going to make this u squared like I want it to be. Du is 1/3 dx. So dx is 3 du. So here we go. So, okay, that's gone. So it's the integral of 1 over 1 minus u squared, square rooted, and dx is 3 du. The cool thing is that the 3 and the 1/3 cancel each other out. Like in the tangent inverse one, they didn't cancel out. They left me, I had a 1/4 and then I got a 2, but they didn't cancel out. They became 1/2. But in sine inverse, they do cancel out. And the reason why is because this number, this 9 got square rooted first, so it got turned down into a 3. And so it canceled out with a 3. With tangent inverse, there's no square root, so the 4 came out unsquare rooted and it stayed 1/4, and it canceled out with a 2 somewhat, but it just became 1/2. So sine inverse is a little different because of that square root. The thing that you factor out ends up getting canceled, which is kind of better. And so the answer for this one is just sine inverse of u plus c. Oh, better turn it to x's. So it's sine inverse of, in this case, x over 3 plus c. So we'll just do the formula a little faster here. I'm not going to prove the formula like I did up above. You would do the exact same steps with substitution, and you'd get the same. End up with the same formula, same idea of a formula, except it's slightly different. So what you want to do is you want to notice the a squared minus x squared, and you go, oh, it's in the square root, sine inverse. So you'd want to figure out what the a is. You got your a and you got your x. The answer to this is just sine inverse of x over a plus c. This is the memorized formula. And there's no coefficient in front like there is with tangent inverse. With tangent inverse, we end up with that 1 over a. And so it's 1 over a, tangent inverse of x over a. In the sine inverse one, it's just sine inverse of x over a. So to give you like a quick example, square root of, 1 over 25 minus x squared square root dx. If you know this formula, you can just go, oh, this is a sine inverse. I can spot it. So a is 5. And this is just, x. X is x. And so this is just going to be sine inverse of x over 5 plus c. And behind the scenes, there'd be a bunch of substitution happening, but we don't have to do the substitution because we're cool that way. Okay. That's the end of this video. I just wanted to show you these two formulas, the sine inverse and tangent inverse formulas, and how we get them using substitution. I figure for some people who are struggling with substitution, maybe seeing another substitution problem and seeing the steps and trying out the steps, and that might help you with substitution. And so that's why I just didn't tell you, here are the formulas, memorize them. I wanted to show how they come out of substitution. It's no new math. And maybe for some of you, the substitution stuff would help. All right, that's it. I'm going to assign a pretty short, directed set of problems involving substitution, including some inverse trig, and you'll see that. But it's not going to be too long because you guys had to watch a lot of videos. Okay.